Problem 2, section 3.7. Find the point on the line negative 3x plus 5y plus 4 equals 0, which is closest to the point negative 4, negative 1. So they want us to find the point. This is my answer. Let me explain why that is my answer. Okay. So you have a line and you want a point closest to the point. You want a point on this line which is closest to this particular point. So the picture is as follows. So you have this line and the point negative 1, negative 4, negative 1. All right. Negative 4, negative 1, not on the line, right? So you want to find a point that is closest to this. Well, actually it is this point. It's perpendicular distance, you see, somewhere here. But any point on this line, you can define its distance. You can find the distance of that point from this point. Okay, and then you want to minimize the distance function. Minimize the distance function means you eventually find the point that is closest to it. Okay, so what is the distance formula? Well, let's remind ourselves. If x1, y1 and x2, y2 are 2 points, distance between these 2 points, the formula is given by square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. To minimize this distance, which has a square root, well, it's easier to minimize the square. If you square it, you get rid of the root and your calculations become easy. So let's square d. That gives us d squared equals, you lose the square root, you have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So you want to minimize this. Who is x1, y1, x2, y2 in our picture? Well, let's call this the first point, x1, y1, and let's call this the second point, negative 4, negative 1. So what's the distance between these 2 points? I'm taking the square of the distance, mind you. So x minus minus 4, that gives me x plus 4 quantity squared plus y minus minus 1, that gives me y plus 1 quantity squared. I hope it's clear. You see, x2 minus x1, y2 minus y1. So you're squaring it. So x2 is this guy, x1 is this guy. So the negative here and the negative here made it positive here. Likewise, the negative here and the negative here made it a positive inside. And that's, now you want to square this. You want to minimize the square function. Well, this is good, except we have 2 variables. So as in the previous problem, we will try to get only one of the variables taken care of. Okay, you want only one variable function, not 2 variables. So how do I get rid of, say, y? Well, notice this point is on my line. And what is the equation of the line? Negative 3x plus 5y plus 4 equals 0. So I can use that fact. So since my point is on that line, I get negative 3x plus 5y plus 4 equals 0. Okay? Solve for y. In other words, move the negative 3 to the other side, negative 3x to the other side. Move the positive 4 to the other side. So that is 5y. To solve for y, divide both sides by 5. You get 3x minus 4 over 5. Okay? So I will use this y in my equation. If you remember, I keep explaining this. You need a function in only one variable. So somehow you have to replace this by an expression of x. We got that. So we place 3x minus 4 over 5 where y is. The rest is same as it is. D squared is x plus 4 quantity squared plus y, which is 3x minus 4 over 5 plus 1 quantity squared. Aha. So we have arrived at a function in one variable. You want to minimize it. Okay. So why don't we simplify this function? Division distributes. So I get 3x over 5 minus 4 over 5 and plus 1. Let me write 1 as 5 over 5 so that I can use common denominator here. Okay, so I've replaced that 1 by 5 over 5. So notice negative 4 over 5 plus 5 over 5 is positive 1 over 5. Okay, everything else is the same. Squaring, squaring. All right. Now this function is defined for all x in R. That is, the domain of this function is negative infinity to positive infinity. Okay, you don't have any denominators, any square roots, so this is safe. Okay. Now to minimize this function, you have to find its critical numbers. So in which case you need to find its derivative. So we have to use chain rule. So this 2 comes down, x plus 4 power 1, and then go inside, take its derivative. Derivative of x is 1. Okay, plus that 2 comes down, this quantity power 1, and then the derivative of the object inside. So that gives me 3 over 5 here. Okay, so let me distribute the 2. Well, I don't have to distribute the 1 because multiplying by 1 doesn't change anything. So that gives me 2x and that gives me 8. Here, I have a parenthesis. I have to distribute this 2 as well as 3/5. Okay. So 2, 3x, and then this 3 goes on the top. So notice 2 is nothing but 2 over 1. So 2 goes to the top and this 3 goes to the top. Denominator, that's a 5 and that's a 5. Plus this 2 goes on the top and this 3 goes on the top. And denominator is 5 and a 5. Okay. Continuing some more, you have 2x plus 8 multiply 3 times 3, 9 times 2, 18x. Denominator is 25. 2 times 1 times 3, 6. Denominator is 25. So common denominator of 25. So let me write 2x as 50x over 25. So that gets me common denominator here, multiplying by 25 if you like. 8. Again, multiply by 25. You get 200 over 25. That's 8. The rest as they are. Why would I do this? So as to simplify. Look, that's an x term and so is this. So combine like terms. 50 over 25x, 18 over 25x, combining them, you get 68 over 25x plus this and this together gives me 206 over 25. That is the derivative. So look, all this because I need to find the critical numbers. Notice this is a polynomial, so it's defined everywhere. So the only way to obtain a critical number is by setting the derivative to 0. Well, derivative is this quantity, set it to 0. Move the 206 over 25 to the right, becomes a negative. Well, multiply both sides by 25. 25 go away. 68x equals negative 206. Divide both sides by 68. X is negative 206 over 8. Reduce it by 2. You get negative 103 over 34. So you have only x, this as a critical number. But domain is everything. In other words, you don't have any end points to test it against. So you have to use the first derivative test, or you can use the second derivative test. Okay? We will see both approaches here. Second derivative test in this case is easy. You take second derivative. This is the first derivative. Yes. So second derivative gives me 68 over 25, which is positive. Okay. In other words, the graph of d squared is concave up. So you see, you have negative 103 over 34. It's going to be concave up. That is, this is going to be a minimum. And since this is the only critical number, this is going to be the absolute minimum. So that's one way using second derivative test. Suppose I'm taking the first derivative test. That is negative 103 over 34. This is a critical number. Remember, that was our critical number. Okay, where we set the derivative to 0. So you know that the slope is going to be 0 here. There are two intervals, one on the left, one on the right. Negative infinity to negative 103 over 34 and negative 103 over 34 to positive infinity. My first derivative, I want to find its sign. First derivative was this function. So choose any test points. So from here, so look, this seems to be something like less than 3, right? Negative 3. So why don't I take something far away? I chose negative 10. Now this being a negative number, I'm taking somebody to the right. I choose 0. Why do I choose these numbers? So that the calculation is easy. So negative 10, if I plug in my derivative equation, expression, x is negative 10. Whatever, this is going to be negative 680 over 25. And this is plus 34 over 5. Okay. I could have chosen 100. See, the point is, this is going to be so large, I'm going to get negative here. Likewise, on the right hand side, if I put in 0, this is going to disappear. So all I have is this guy, positive. So positive. So where I'm negative, my function d squared is decreasing. Where I'm positive, derivative is positive, my function d squared is increasing. So it's decreasing here, increasing there. All right. So which tells me negative 103 over 34 is going to give me a minimum, the minimum. Okay. Now, so this is the x coordinate. You see, x coordinate. How do I find the y coordinate? Well, we did solve y coordinate somewhere here, you see, because your point was on the line given by this equation, notice. Okay, so I'm using, if you remember, we used this equation to find an expression for y, which gave us d squared, right? You wanted to get rid of y variable. So you have an expression for y. So I'll plug in 103 in that expression. Okay, so you could simplify it the way I have done, or you could actually write down this expression there. Okay, so let me simplify it. I'm substituting x equals negative 103 over 34 for x. So 3 is nothing but 3 over 1 times this quantity. So multiply the 3 with the numerator, minus 309 over 34 minus 4. Because I'm going to need common denominator, I'm going to multiply 4 by 34 and divide by 34. 4 times 34 is 136 divided by 34. Okay, negative and a negative, you see. So combine it together, you get negative 445 over 34. I'm dividing by 5. 5 can be thought of as 5 over 1. Division by a fraction is multiplication by its reciprocal. Now you can reduce the 5 In 445, that is an 89. So I get negative 89 over 34. So that is my y coordinate. X coordinate, y coordinate. Submit. You're correct. Until next problem.